This is the controller that controls the tooth cutting, which is based on an Arduino Nano, and the constituent parts are very inexpensive, and the software which Roland has produced is very good. I had a little bit of a problem because I got a much lower gearing ratio than he had, but that's now resolved, and I've got that working. Right, I need to set the number of teeth, so if I set this to 10, enter it, then it tells me there's 2,000 pulses for each tooth, and then it tells me those 2,000, and this will tell me how many pulses that are counted on the encoder. And that's given me a turn which is 2,000 pulses, what it should be, and that's what it actually was when it made its turn. And then to do all the teeth from here on, so that's the first tooth that's been cut like that. The second tooth, you go to the up arrow and press enter. So that's cut 10 teeth. If I make it 11 teeth, it then says it wants to go back to 0, and at that point it winds the rope up and the bungee cord to remove the backlash, and that part of it isn't working, so I restrict myself just to the number of teeth. And I don't think I can get out of this now. No, I can't. It says it's going to go to there, but it doesn't. I can't get out of it. And I know what's going to happen. It gets... Oh, it's done it. Well, that's amazing. I don't believe that. It's actually done it. The other one command that it has is to reset anything. So if I get to a point where I made a mistake somewhere and I want to just reset everything, you just press the reset button and then enter, and it gets you back to your beginning screen again. This is inside the controller. This is the LCD display and its board that goes with it, and the line that controls the LCD board goes back to the Nano. I've got the Nano sitting on a PCB which I bought one of these and just cut off the bit I needed, mounted the Nano sitting over here so I could extend the lines out easily, and you have to excuse the huge size resistors. It's just that's what came when I ordered them, and I didn't order really the right thing. The Nano's sitting down here, you can hardly see it, it's so small. and that's the amplifier, sorry, that's the controller for pulse width modulation for the DC motor, and it gets its signals from the Nano via this yellow and red line. The encoder line is this one here, and it gets its power from the board. I had a problem with the Nano which didn't do 5 volts out, and in the end I used on here I've got a 12 volt rail sitting up at here, and I took 12 volts from there into the encoder, and I've got 12 volt supply going to this, and then I've got at the bottom a 5 volt supply which is coming from this connection here to the board via the USB socket, and I haven't yet wired this in properly, but everything else is connected up, so it's in a finished state, and all I need to do is to cut just a slot to have this to come out here, and that will give me my 5 volt supply. I've got a 12 volt supply going in here on a simple brick transformer, like that. I like using the connectors here, which are the aircraft style connectors. Those are very good, nice and strong, and don't get any wear when you move them in and out. And really there was very little to do in making the board up. You can see there's very few wires on there, and basically a lot of those are just simply taking the negative or ground across from one side of the board to the other and running it along a rail at the top and the bottom, and then having the 5 volt at the bottom and the 12 volt at the top there. Then that's more or less it. Oh, this line here is the buttons, and they go down to the Nano there, and it's all as per Roland's original setup, and really haven't had to change anything much. So I'm going to just finally put some nuts on these pillars here and screw this together. So that's it. This is the final installation that I'm using. You can see on the side here the black case of the right angled motor drive, which is essentially a wiper motor, and if you look up at the top you can see up at the top here the same unit exactly as I've got down here. And I've made a simple plate up that sits on top of here and uses 2 holes that I'd pre-drilled and tapped for taking the rotary table that I've made. The main problem with the rotary table is getting everything far enough to one side, and here you can see it demonstrated that this here is running over the top of the tailstock, so it's got a bit more surplus room to go up to here, about another 20 millimeters before it's out of room, and that's where the blank is mounted on at that point. So there is a bit more room. This top slide can go further this way a little bit, so it could take a larger, I've got this tightened up at the moment, but it can take a larger wheel blank in here, or alternatively it could be mounted further up here and run out to this side. So there's two alternatives, and I think I worked out you can get about a 6-inch blank in. The other alternative, of course, would be to move this further that way. But however it's done, it's not too much of a problem. Whenever you're cutting gears, you have to make sure that the table is locked, the cloth side is locked, and everything is tightened up. So all these collet holders and screws and everything must be tight. On the end here is the device that's used to clamp the shaft here. You can see there's a slit down there and a slit up here. Sorry, go around that way. A slit down here and a slit up there. So that nips together when that's tightened up. And that works very well. It's very simple, but it works. I was going to fit a bungee cord around the spindle here, but it doesn't look as if I need to. The way that the software works, it has several goes at trying to get the lowest number of pulses the lowest number of error pulses in trying to reach the calculated figure. So it will be under 10 for any advancement of a tooth. So for a cutter like this, it's not a problem. It might be for very small cutters. I don't really know. I'll have to try it. But so far I've only cut 2 wheels, and the second one was using this. It's about that's a 24 dp cutter, which I think is much the same as one module, but I'll have to check. I showed all the bits that fit inside here where the encoder sits. There's a flexible joiner, and underneath here, you can't see them here, but there's 2 holes drilled underneath here in the plastic to allow the grub screws to be tightened up that hold the shaft of the encoder onto the shaft of the rotor. This is a rigid enough setup. It is adequate for cutting gears, and I'm not intending to do anything more with it, and just use it. The only slight snag is when it's cutting from this direction, as it sprays swarf all over the place, so it would be quite handy to have something on there to collect the swarf in so that it didn't go all over everything. But that's probably being a bit nitpicking. I haven't quite finished everything for the control box here, down here. That I might have a go at a TFT screen and have a touch control. That might be quite fun to do, but at the moment that one works, so it's very inexpensive, and has only got one fault, which is that it doesn't wind the rope back at the moment for the bungee cord. But I'm not using anti-backlash because there's hardly any movement in there, and for the moment don't need to use it. So I think I'm quite happy to just leave that as it is. I've adjusted the software so that this does turn without a problem, except if I happen to have tightened up and locked the spindle, then it will start to make a mess of the steps. I've had that happen once when I was doing the teeth. All my controlling of the cutter here, well, the cutter stays stationary, just simply turning round. The work here slides up and down the body of the lathe, and it's controlled by an electric motor There's a stepper motor at the end here, you can see, and that is controlled at this end by an on-off switch, and towards the back, it goes towards the back of the lathe, and that's towards the chuck end of the lathe, and that's the speed, and that works excellently. That's really good. So I'll just show some cutting of the teeth just to show you that they work. The only thing is, if you are slightly if you get slightly concerned about it, the teeth are slightly leaning because I didn't get the cutter quite on the centre height. To get the cutter centred, I put a point. This is a point that I'd scribe a point that I'd made years ago, and I had originally used it for finding the centre height of tools, but it's quite handy here. So if I put a point in this here and measure up against get it centred onto this point, then I know that that is set at the centre height, and all I have to do then is to make sure that this. Now, while I've been talking, I just realised when I did this, I didn't lock the quill, and it could be that that was producing a little bit of vibration, and I didn't lock the head either, so there might have been some vibrations coming from that. There's just so much to do, and this is, I say, the first time that I've tried to use it. I've taken the right angle drive wiper type motor to pieces just so I can investigate how I can fit an encoder onto the end of the spindle here. It'll have to clearly come through the end cover. The motor is very simple to take apart. You undo these two screws. I've taken the plate off the end, but there's no need to take it off. I was just investigating what was underneath it. When you've taken these two and this off, then you can unscrew this screw from the worm, and the whole lot will come out. This assembly of washers and a wavy washer. There's a wavy washer there which goes at the front, and those two go either side of it, and there's one washer that goes in the back. So it's very simple, and of course, being new, it's no problem about getting things apart. Holding the brush that's just come a bit loose, the other one's still in place, so that's still in place. And when I put this back in, I need to make sure that that's screwed in, and then this commutator fits so that the brushes are pushed apart, and then the tube can go in afterwards. That should be fairly simple to put together, and it's a reasonably good sliding fit on the brush on the ball racers. So I think what I'll do now is I'll mount this in the lathe, and I'll see about turning a hole and putting a thread in it. I have the spindle of the electric motor set up in the lathe. I've got a fixed 3-point steady on the bearing surface here. I've tried to make sure the points are nice and clean that are touching on it, and I'll make sure there's oil on there while I'm turning. And what I'll do is I'll just turn the centre in first, and then drill it out. I think probably I'll do M4. is cutting through the steel, whatever steel it is. It's fairly hard on the outside, but the inside seems reasonably soft. So I'm just drilling that through with a centre drill. I'll just stop and put a little bit more oil on because I don't want to mar up the surface. I'll now drill in. I'm going to drill for M5, I've decided. Millimeters in. It's 6 millimeters in. Nearly 8 millimeters. That should be sufficient. Now I've completed this, and inside you can probably just about make out the thread. It's an M5 thread, 8 millimeters deep, and this is, I think, case hardened steel. The outside of it was a bit tough, but the rest of it was fairly simple to get through. And I've just got a very slight marring up on the side there. Very slight marring up on the side here, and I'll just put that in the lathe and put some fine emery paper on just to take that off and check that it fits into the ball race properly. I've made the basic parts now to join the encoder to the shaft. This is the joining piece. Where I threaded it, and it ran, when I checked that it was right, it ran nice and true. I found that the end of the shaft wasn't completely square, so I just took a shaving off that, and I shall Loctite that in. And then I found in my box a coupler here which is absolutely perfect for joining these two. It's small, really quite flexible, and has got 2 small grub screws, so I'll join that with that and that, so that's all going to work out well. And then I've got to make a piece to hold these in place, a plate to go on here, and then that'll be virtually complete. So that's my next task after having got this screwed together and made up. So, and I've just tidied up the casting here where I've just squared it so that it's going to fit together snugly. I'm set up now to cut 30 teeth down this plank, and I cut the 20 tooth wheel alright, so this should cut alright. It's just that it's fairly complicated to cope with filming and everything else at the same time, so let's hope I don't forget anything as we get going. Let's cut all the teeth. Let's have a close-up look at it. Looks pretty good. It certainly seems to have cut even-sized teeth all the way around, including the last bit. Right, I've just matched this up against the wheel that I was copying, and the diameter's not quite right because I hadn't got the blank quite the right size, I don't think, but you can see it's exactly the same number of teeth, and they seem to be nicely cut. I made a couple of errors while I was doing it because I'm not used to doing it. It's only the second time I've done it, so it's not perfect. But it's not too bad at all.